Hi, second grade teachers. Today we're going to take a look at Unit 3, Measuring Lengths and Distances. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 3. In this portion of the video, we are going to review the AKS and the Indicators of Achievement, or IOAs, for Unit 3. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and the IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and the IOAs in this unit are paced in detail. This unit has two AKS, AKS 5 and 2. Under the AKS, you will find the Indicators of Achievement, or the IOAs, that we are teaching at this time. Notice for AKS 5, we are focusing on IOA 5A, 5B, 5C, 5D, and 5E. For AKS 2, we are focusing on IOAs 2C, 2D, and 2E. You will also see that we have provided you with the state coding at the end of the IOAs, so that if you are looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. IOAs without state coding at the end are specific to Gwinnett. AKS 5 is our measurement and data standard. In Unit 3, students will construct simple measurement instruments to build understanding of 1-inch units and compare unit models to rulers. Students will estimate and measure objects and distances to the nearest whole unit using appropriate tools, as well as measure to determine how much longer one object is than another, and express the length difference in terms of standard length unit. Students will also use a number line diagram to represent whole number sums and differences of standard units. It is important to mention here that units of measure for second graders are inches, feet, and yards. Finally, students will revisit asking questions and answering them based on gathered information, observations, and appropriate graphical displays to solve problems relevant to everyday life. Let's take a closer look at the IOAs that will allow students to demonstrate mastery of AKS 5. In IOA 5A, students will construct simple measurement instruments and discuss how measuring with the iteration of individual 1-inch units, such as 1-inch tiles, compares with measurements using an instrument such as a standard ruler. In the past, we have incorporated the skill into our measurement unit. Now it has its own IOA. In IOA 5B, students will estimate and measure objects and distances to the nearest whole number using units, appropriate tools such as rulers, yardsticks, and measuring tapes. As stated earlier, units of measure include inches, feet, and yards. Students will also use what they know about unit benchmarks, such as small paper clips measuring about the same length as an inch, to justify their estimates. In IOA 5C, students will measure and compare lengths to determine the difference between the measurements, or how much longer one object is than another. Express the length difference in terms of standard length unit, and use tools such as rulers, yardsticks, and measuring tapes to obtain measurements. In 5D, students will continue to formulate statistical investigative questions to explore an authentic situation in their classroom. Pose questions, determine up to 4 categories of possible responses, collect data, represent data on a picture graph and/or a bar graph using a single unit scale, and interpret the results. And finally, in IOA 5E, students will represent sums and differences presented in practical mathematical problems on a number line diagram. Later in Chapter 2, Unit Pacing, you will notice that IOA 5E and 2C have been clustered together to include 1- and 2-step measurement word problems. AKS2 involves students continuing to add and subtract numbers using a variety of strategies based on place value, part, whole, and properties of operations. Students will also continue to work on building fluency with addition and subtraction within 20 and within 100. In Unit 3, students will continue to add and subtract numbers within 100. Let's take a closer look at the IOAs that will allow students to demonstrate mastery of AKS 2. In IOA 2C, students will continue to solve authentic mathematical problems involving addition and subtraction of two-digit numbers. However, in Unit 3, students will also add up to 3 two-digit numbers using strategies based on place value and properties of operations. The focus will be on solving problems within 100. In IOA 2D, students will add and subtract fluently within 100 using strategies based on place value, properties of operations, and/or the relationship between addition and subtraction. They will also use numerical reasoning and student-chosen flexible methods and strategies to solve mathematical problems accurately and efficiently. These mathematical problems will include all problem types. In IOA 2E, students will add and subtract numbers within 100 in the context of 1- and 2-step word problems, including a variety of problem types that have unknowns in all positions, including result unknown, change unknown, and start unknown. They will also use drawings, objects, and equations with a symbol for the unknown to solve 1- and 2-step word problems. IOA 2C, 2D, and 2E will be clustered together in our suggested pacing. Teachers, take note, although it is not shown here, IOA 2A, fluency with addition and subtraction within 20, is ongoing. Reaching fluency is an ongoing process that will be continued through number talks. Students should know all sums of 2 one-digit numbers by the end of grade 2. In this portion of the video, we will look at the pacing guide to see how the AKS and IOAs have been paced over the course of the unit. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS or IOAs and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. At the top of the pacing guide, you will see the name of the unit, the big ideas for the unit, and the suggested pacing. This unit will focus on measuring lengths and distances, and the suggested pacing is 4 weeks. The unit has been divided into 3 parts: estimating, measuring, and comparing the length of objects or distances to solve real-life problems and analyze graphical displays of data to answer relevant questions; solving addition and subtraction measurement problems within a standard unit of measurement on a number line diagram; and adding and subtracting using part-whole strategies, properties of operations, and place value understanding within 100. The pacing guide is set up with a list of AKS and IOA or IOAs, which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column provides the learning progressions for the AKS and IOAs, whether this be the concrete representational abstract progression or the progression between specific learning targets within the IOAs. And it also includes the suggested manipulatives for this column. Now, over to the right, this column provides resources to guide instruction, such as GCPS traditional and task-based lessons, as well as Georgia DOE resources. Unit 3 begins with the clustering of IOAs 5A and 5B for a suggested 6 days. We are starting with this cluster of AKS because allowing students to construct student-created rulers using 1-inch colored tiles builds their understanding that the length of an object is the number of spaces between the hash marks and not the number of hash marks on a ruler. This understanding will then progress to students estimating and measuring using tools such as rulers, yardsticks, and measuring tapes. The progression over the 6 days consists of students concretely constructing and connecting student-created rulers with 1-inch colored tiles, and then moving to connecting student-created rulers to a standard 12-inch ruler. Students finally progress to using rulers, yardsticks, and measuring tapes to estimate lengths using inches, units of inches, feet, and yards, then use the appropriate tool to measure to determine if estimates are reasonable. Students progress to estimating and finding the measurements of pictures of objects with a ruler and/or a broken ruler. After students have estimated and measured objects and distances to the nearest whole unit using appropriate tools, students will move to IOA 5C, where students measure to determine how much longer one object is than another and express the length difference in terms of standard length unit for a suggested 3 days. Students will have more practice with measurement word problem solving later in the unit with IOA 5E and 2C. The progression over the 3 days consists of students using measuring tools to measure and compare the length of 2 objects. Students progress to comparing the length when given pictures of objects and measuring tools. Students represent the context with equations and symbols for the unknown. And finally, in the abstract, students move to visualizing the measurements and writing equations to determine how long one object is than another. Students will use comparison language to reason about their answers. Students will revisit IOA 5D for a suggested 2 days. For the 2 days, students will engage in a Georgia DOE task-based lesson where students create bar graphs to show data about the habitats of the eastern box turtle. Students are going to analyze the data and progress to asking a student-generated statistical question to gain understanding and information on what students in the class think the reason is for the declining eastern box turtle population. Students will then collect and create a bar graph and/or picture graph so they can analyze and interpret the data received from the survey. All the information needed to support student success with this learning plan has been provided. After working with analyzing graphical displays of data to answer relevant questions, students will move to IOAs 5E and 2C. These IOAs were clustered together to allow students to engage in relevant measurement word problems involving addition and subtraction, where students represent the sums and differences of those problems within a standard unit of measurement on a number line diagram. The suggested 5-day pacing consists of students solving 1- and 2-step measurement problems of various problem types. Students will write equations with an unknown and progress from using a measuring tape to solve the problems to connecting a measuring tape to a number line as a strategy for solving measurement word problems. 1- and 2-step word problems have been included here because the Georgia DOE includes 1- and 2-step word problems under the strategies and methods for their IOA 2.NR2.3, which is Gwinnett's coding of IOA 2C. Finally, in this unit, we will revisit IOAs 2C, 2D, and 2E. Students will continue to use multiple strategies to solve addition and subtraction word problems within 100 for a suggested 3 days. The main focus of this 3-day progression will be adding up to 3 2-digit numbers using strategies based on place value and properties of operations. The students will begin solving problems using base 10 drawings and connecting those drawings to the expanded form, then progressing to using the relationship between addition and subtraction, and then finally using associative property to solve relevant word problems. This progression was used because students are revisiting these IOAs. These IOAs were introduced in Unit 2. Chapter 3 of the video will highlight specific instructional strategies that will be utilized in Unit 3. Please refer to the Analyzing the Standards, ATS, for guidance on additional instructional strategies for each IOA. We are going to begin by looking at strategies for IOAs 5A and 5B. For these IOAs, students will need to be able to construct simple measurement instruments and discuss how measuring with the iteration of individual 1-inch units, such as 1-inch tiles, compares with measurements using an instrument such as a standard ruler. They will be able to estimate and measure objects and distances to the nearest whole unit using appropriate tools such as rulers, yardsticks, and measuring tapes. As stated earlier, units of measure include inches, feet, and yards. Students will also use what they know about unit benchmarks, such as a small paper clip measuring about the same length as an inch, to justify their estimates. It is important for teachers to keep in mind first graders measured items using non-standard units. Second grade is the first time students are introduced to a standard length, such as an inch. The focus of this example will be strategies for constructing a simple measurement instrument using unit models and comparing unit models to rulers. This allows students to build their understanding that the length of an object is the number of spaces between the hash marks and not the number of hash marks on a ruler. Our instructional strategy today, teachers, we're going to use a colored tile to construct simple measurement instruments for our students. This will address IOA 5A. And in this IOA, it simply says students will construct simple instruments and discuss how measuring with the iteration of individual 1-inch units, such as 1-inch tiles, compares with measurements using an instrument such as a standard ruler. And this is indeed a 1-inch tile. It's 1 inch all the way around, and we're going to use it to create an instrument that measures in inches because, as I stated, this is a 1-inch colored tile. And the way we can prove this to our students is we can discuss different types of benchmarks for an inch. And I'm going to focus on the body benchmark, which is the pointer finger from knuckle to knuckle. So once we show our students what we're going to use to create the instrument, then we can prove to them that this is in fact an inch by using our knuckle to show that it measures the same from knuckle to knuckle, meaning it is an inch. Therefore, we can use this colored tile to create a simple measurement instrument. Now that we have proven that our colored tile is an inch by using the benchmark of our finger from knuckle to knuckle, I can build my instrument. I know that I've already proven that this is 1 inch. So I can put a 1 on this because the measure from the first part of my tile to the second, to the end here, is 1 inch. Then I could line up another tile with that. And I know if this one is 1 inch and I'm connecting the yellow tile with it, then from the beginning of my first tile to the end of my second tile is going to give me 2 inches. And it's important to keep in mind that the measure is from the beginning of the tile to where the tile ends. It's the space that we're counting and not where the tile ends in of itself. So from the beginning of the red tile to the end of the red tile, that space is 1 inch. From the beginning of the first red tile all the way to the end of the second red tile, the yellow tile, this space from here to here is 2 inches. And it's important that we emphasize that so that students will not get a misconception. And then we will continue this when we add the third tile. We know that from the beginning of the first tile all the way to the end of the third tile, from here to here, measures 3 inches, because we know that each of the tiles is an inch. We're counting the spaces. Once you have connected all of your tiles, you'll have an instrument that looks like this. These are the tiles all connected, and they have been taped together so that they can be used as an instrument. And remember, our tiles are 1-inch tiles. So I know that this instrument is going to measure in inches. I also know that when measuring, the length of an object is the number of spaces between the hash marks and not the hash marks on this tool. So our lines right here, we're not counting these lines. We're counting the spaces. So as I said earlier, from the beginning of my first tile to the end of my first tile, that measures 1 inch. From the beginning of my first tile to the end of my second tile, that length is 2 inches. We're looking at the spaces. So it's very important to emphasize that. Now we can take our tool that we know measures in inches and begin to measure everyday items around our classroom. So let's take a look at a box of Crayola markers. We've seen these in the classroom. Students are probably bringing them in as part of their supplies. Now, what I want to do before I even start using my student created ruler, is I'm going to bring in IOA 5B, which is the estimate part of that. I want to estimate just by looking at this and knowing that from knuckle to knuckle is an inch. I'm going to estimate that this box of markers is probably about 6 inches. So I have a good estimate in my head, and now I'm going to actually use my student created tool to measure. I'm going to make sure I line up my box at the very top with the very top of my student created ruler right before my 1 right here. And I'm going to go down to where it ends. And I can see that my box of markers measured 7 inches. So now I'm thinking I estimated 6. So that was a reasonable estimate because it actually measured 7 inches. Now I could also show my students how they could turn the box and they could measure it this way as well, as long as it starts at the 1 and it's lined up at the very tip of the marker box. It goes all the way to where the marker box stops, and I can see that that indeed is 7 inches. Now let's repeat that same process with measuring a pair of student scissors. So, as I stated earlier, we want our students to begin estimating, which is pulling in that IOA 5B. I'm going to look, and I know that my body benchmark is my pointer finger from knuckle to knuckle, and I'm thinking about that benchmark, and I'm going to make an estimate that these scissors are probably about 4 inches. And then I'm going to get the actual measuring tool. I'm going to make sure I line it up with where my scissors begin. And then look where they stop, because I'm counting the spaces. Remember, the distance from the beginning of my scissors down to where they end is about 5 inches. So I know that my estimate was reasonable because the actual measurement of my scissors was 5 inches. Again, this works the same way. Students can turn, and you can show them how they could also measure horizontally this way, and they can see it's lined up with the beginning of the scissors to the end, and these scissors measure 5 inches. After students explore measuring with the student created ruler, introduce a standard ruler. So you can see I have here the student created ruler that we made, and then the standard ruler. This can be shown to the students, or you can have the students in partnerships, each have their own student created ruler and a standard ruler. This is a great strategy for students to make connections between the standard ruler and the student created ruler. And what you can do during this time is ask questions like, how are they alike and how are they different? What are the units? What do the numbers mean? What are the marks for? This can be done as easily as an activating strategy. Once students have made connections between the tools, the teachers will be very explicit about what the students may or may not have noticed. You want to point out things as noticing how the ruler begins at 0, and that's where the beginning of the colored tile begins at 0, and how the first tile, the red tile, ends at 1, and how we've discussed how from the beginning of the first tile to the end of the first tile measures 1 inch. So it shows a 1 right where that tile ends. And then reiterate as well with the second tile. From the 0 to the end of the second tile, we notice that the ruler has a hash mark there that says 2. So that means the distance from the beginning of the first tile to the end of the second tile, right where that 2 is, that means that measure is 2 inches. We really want students to understand that we are counting the spaces and not the hash marks here, because that's a common misconception for students. Teachers can continue discussing this going all the way to 12 if you like. You can go next to 3 and say from the beginning of the first red tile, which is starting at 0 on the ruler, to the end of the third red tile, there's a hash mark there that says 3 inches. So we know that the space from 0, which is the beginning of the red tile, to the end of the third tile, that space is 3, that length is 3 inches. This progression is an excellent way to support students as they move into learning to use number line representations. So now let's take a look at a progression for moving to number lines that Van der Waal has mentioned. Van der Waal shows in his Teaching Student Mathematics book that this is the proper progression for moving into the number line so that students can have success with using it as in their representations. And as you notice at that first step, we can see clearly the colored tiles are there, and the students are learning how to count the spaces and not the tick marks here, and they can number them. The second step is similar to the first, but it shows now the actual hash marks that we started to see on the standard ruler. So that's the second progression. And then third, which we will discuss later in this unit of students using a number line diagram to solve problems, they move into what looks exactly like a number line. The colored tiles have gone away, and the students now understand that it's the distance from one number to the next and not actually counting the tally marks. And then they can begin to use these in their representations, not only just to measure, but when they're solving mathematical problems with addition and subtraction. And then finally, they would move into that open number line, but they would have had to have many experiences using these types of number lines in order to be successful with the open number line. And as I stated earlier, this video highlighted specific strategies that will be utilized in this unit. Please refer to the Analyzing the Standard, or ATS, for guidance on additional strategies for each IOA. So, which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. from the Georgia DOE's Comprehensive Grade Level Overview. To ensure completion credit in PD&E, please be sure to complete the following Google form. Please scan the QR code in order to get the Google form. Thanks for watching.